And we are recording.
Brothers. Cloud Brothers.
Cloud Brothers.
I'm going to start off with subscriber dad joke of the week.
What do you call a fish with no eyes? So,
I got better one. I got better one.
Oh, you do?
Got better one.
God.
I'm friends with 25 letters of the alphabet. I don't know why. Quality dad jokes like that, like and subscribe. Gotta get that out of the way early and often, right?
Okay. Yep. How does a polar bear build his house? It glues it together.
It glues it together. That's
glues it together. Yeah, thank you. Yeah, for more quality content like this, like and subscribe to the Cloud Brothers only on YouTube. So
I have this. I had this idea.
Yes.
I'm going down the Kubernetes rabbit hole.
Yes, rabbit hole.
Sucked down into the rabbit hole. Like I'm kind of at that same point where I'm like, what's this cloud stuff all about?
Right.
And I'm like, hey, what's all this Kubernetes stuff all about? It's not going away. So, in my spare time on my YouTube feeds, this stuff showing up in my YouTube feeds.
Yeah. So follow the right rabbit.
Yeah. So I previewed this a little bit last night, and I think it would be a really good thing for you to watch. So we're gonna I think watch it and critique it and et cetera, et cetera.
So what we're looking at is this video you found. We're going to do a reaction video, I suppose. This video is coming from KubeCon, depending how you like to say it, Cloud Native Con from 2017, and it's about building Helm charts from the ground up and Introduction to Kubernetes by Amy Chen from Heptio. And we are going to press play without further ado.
Hi, everyone.
Hi.
My name is Amy.
Hi, Amy.
I recently joined Heptio on Friday, so I believe today is my 5th day of work. So that's pretty awesome.
Congratulations, Amy.
And prior to this, I actually started in the Kubernetes container space in March of this year, and I graduated college in January this year. So it's been a crazy, crazy whirlwind, y'all. And so this talk is sort of like my path and like my journey of understanding Kubernetes and like containers and this whole crazy world in which Helm was a major component, which I'll talk about at the end. I'll note that there's like some like Googleable keywords on like the bottom left of the slides. I'll post them up on my Twitter at some point, but it's like great if you want to like delve further into each topic. So again, this is geared toward beginners, but once again, if you're interested in learning how to teach others about Kubernetes, this is also a great talk. So in infrastructure, your main goal is to always prepare for failure,
right?
I thought it would be good to look at. There is no trust in the sense of like, I don't really want to trust my app developers, and I don't really need to trust my app developers. And everything in the system, it needs to be able to fail, right? So the question is like, how do we do this? So Kubernetes is one of those great tools that allows this, but at the base of it all is containers. And the question is that a lot of web app developers like start with is, how do you run your application in the cloud? So the core concept of the cloud, right, is that everything is ephemeral, everything dies, things are complicated, networks goes down, like it's the whole just crazy field distributed systems where there's like tons and tons of papers, right?
Yes.
So what we want to be able to do is build trust in services that we always want to have available, right? Like if you have a web app, for instance, which is the most like tangible thing that I usually use as an example, is you always want to be able to access websites with low latency and you just want it to work, right? As application developers, like usually they don't really need to think about how the deployment process works, right? So this will sort of like guide you through all of that from a web app onto Kubernetes.
Cool.
So there's lots of issues that we need to think of as infrastructure engineers or DevOps people, some like
DevOps
infrastructure
people,
folks. We need to expect things like high unexpected traffic, application failures, scalability, availability, efficient resource utilization. For instance, if you work at a massive company like Google or Microsoft or Amazon, right? Like if you save even 1% of resource utilization, that's like a bajillion dollars. Like it's a lot of money.
That's a lot.
Bajillion is a very accurate term.
Technically accurate.
Scientific.
So usually how I start off when I have an audience of mainly web application developers is first you need to like start with a base building block, right? So what is a container? A flaw that I find when people teach this is like they start off with, oh, like a container is a Linux thread. And that's like, I feel like the worst way to approach that. Like, yes, it is, but you don't need to tell people that at the beginning. Right? Like, what is a Linux thread? Like, can people actually
what's a thread?
Like, really, truly explain that correctly when they're first beginning? So what I like to start off with is a container is a baby computer inside another computer, where the baby computer is a container and the other computer is a server, right? So why would you want a baby computer inside another computer? The idea is that the baby computer is easier to transfer around, there's resource isolation, and it also is able to encompass your application environment, which I'll be able to talk to you about next.
Nice.
So a common conceptual comparison is a virtual machine, but it is very different in the sense of containers are much more efficient, but there's awesome papers and things like that to be able to describe the differences between the two. And ultimately, containers are a way to abstract away your infrastructure. So here is kind of like my pseudocode-ish example that is another way to lead into how to get web application developers like deploying their applications onto a container. So what we have here is like, let's focus on the image on the left, is we have our server, and then we have our container, and we have a bunch of configurations that we have on our Docker file, right? So on our container, what I want to always consistently deploy our web application on is Alpine, and I want it to be on Python version 3.7, and I have like a lot of setup scripts and things like that, and I want my web application to consistently be in the same environment, right? The idea is that locally, like you have a bunch of configurations and things like that, and like shit just goes wrong when you put it into production if your environment is not consistent. So containers provide the consistency for you. So on the right here is where we have our configuration file. You'll see that we have the Python Alpine image. In the run line, there's a bunch of setup scripts. What we do is we copy the local application onto our container, and it builds that into our image. And what we're doing is then exposing port 80. After that, what we have is the container, but that's not enough, right? So it's complicated. Our container is going through an existential crisis, poor little container. It's asking questions like, where should I live? So this goes under the realm of scheduling, right? How do I talk to other containers? So this goes under the realm of networking. How do I talk to the world? So this goes under the realm of routing. And what happens if I get sick? So let's talk about like failure recovery. And there's like a whole bunch of topics that this can expand into, right? And like no one really wants to manage this on their own. So what happens? Hey, we're at KubeCon, so Kubernetes, of course.
Yeah.
Who would have thought? So Kubernetes, obviously, is a container management platform. That's why we're all here, right? And the way I like to describe it is that we have a bunch of like super fancy abstractions to organize baby containers, right? And this is sort of the answer to all the previous questions that we had before. So this is sort of the basics of everything. I'll try to like run through them super quickly so that we can go to the Helm demo, since this is a Kubernetes conference. So hopefully, or not hopefully, but maybe most of y'all probably know about this. So some containers are tightly coupled together, so therefore we need to be able to have an abstraction to be able to schedule them on the same server together, right? They want to be co-located. So we need more ways to organize containers, and that's where pods come in. So pods are essentially a scheduling unit. They're the basic unit of Kubernetes. They contain one or more containers in a pod. Each pod is given an IP address within the cluster to be reached. Note that you cannot reach this IP address outside of your cluster. Pods, they can be confusing, but what you want to be able to know is that you rarely ever have more than one container with a pod due to scheduling issues. So if something happens, you can't really control which container gets killed. And so that's like the main reason why you don't want to have more than one container within a pod. So
Fair
next,
enough.
what we have are deployments. So what a deployment is a group of pods. And here is where we have the concept of actual state and desired state, right? So deployments, what they do is they help your pods reach your desired state. So for instance, what you could have is you can specify a number of pods running in your cluster. So let's, for instance, say we want to have 3 of the same pods, or we want to have 3 of the same pods running in our cluster always, right? So that's what we call replicas. Let's say one dies or you kill it, the deployment controller will make sure that there's another pod spun up to make sure that you always have 3 pods. So that's the idea of the desired state. No matter what's happening, your deployment controller will make sure that we will always work towards to get to the state that the deployment is defined as. So again, let's say you have 3 replicas. If you kill one, deployment controller will make sure it'll spin up another pod. Now we have another organizational concept called services. So what services refer to are a group of pods or deployments. It has nothing to do with desired state. So let's pose this problem, right? So recall that each pod gets an IP. So when they die or get killed, their IP can change and it's not a reliable IP to always hit. So let's say you have a group of pods, for instance, front end, another group of pods called back end. They need to talk to each other and be able to keep track of each other. And you don't want to do this based on relying upon any sort of single IP address, right? Because again, they're not dependable. So what services do is that they define a group of pods and a dependable endpoint to be able to communicate to one another. So for instance, you can have your front end service hit up your back end service, and they can transfer information back and forth between these groups of pods that work together, or pods or deployments. And the last sort of concept is how we sort of route traffic from the world onto our cluster. So this is called an Ingress Controller, and this is how traffic outside the cluster is routed inside the cluster. So what it does is it routes traffic to internal services based on things like your host and your path. In my demo, I'll actually be I'll be routing it to a port, and I won't have an endpoint, but I'll have another diagram to show you that. So let's do a summary and run through, and then next we'll do demoing time. So here what we have is the internet, and what we want to try to reach is our Ingress controller. So we'll hit an IP or domain or whatever, and then what will happen is let's say we hit up endpoint foo, then it'll hit up service A, and then be able to serve back whatever service A wants to give back to you. Same for endpoint bar or baz, it'll hit up service B and C respectively. Within our services, again, we have what are called deployments and pods, and those are in charge of, so deployments are what is in charge of making sure that making sure that there's always a desired state to be achieved. So,
I think you just wanted to get on
that we can talk about is how do we version control a deployment.
Five days in.
So what we have is great, right? So what we want to be able to make sure is how do we keep track of each deployment that we have? So let's say we have a specific deployment with, let's say, Nginx 1.12, right? And then the other thing that we want to add is a new Ingress endpoint, right? So we want to be able to couple these sort of resources and changes together. And so this is where Helm comes in. And this is actually the tool that I used to deploy all my deployments when I first started, because I thought that existing tools were a bit confusing. So this can help you kind of manage each of your deployments and also the cluster state. So Helm, yay! So this is kind of do a cursory overview of this. So this is what is called a chart. And so a chart basically defines a group of manifest files. And so that is sort of the state of each deployment that you have. And you can define a lot of metadata there. And it's super awesome. And this is how we structure a chart. This is information that you can look on the documentation. But we have chart, and we should have, that should say templates. And then we have all of our templates under there with all of our manifest files. And then all I do is I can do Helm install, and then I can show the different deployments that I have out with Helm list. We can do things like rollbacks, we can do linting, and all of that I will show you in a second. So this is our demo preview. I wanted to sort of show you a picture of what's going on before we actually look at any YAML code, because I find that pictures for me, I need to be able to I'm a very visual person. I need to be able to see what's going on. So what I'll do in my demo today is I have a mini cube set up to set up my cluster. What we're going to do is we're going to be able to hit up that endpoint. I think it starts with 192, and that's essentially the endpoint, the IP address where the internet is coming in, right? And then what that will hit is our Ingress controller. On our Ingress controller, what I want to be able to do is expose port 443, and our Ingress controller will be called Nginx Ingress. That will then route traffic to our Nginx service named Nginx service. Pretty imaginative name. And then 443 will route traffic to the exposed port on the service, port 80. And then what we'll do is, I'll explain the selector in a second. So inside our service, what we have is a deployment of 3 pods right now. And our container, we're exposing port 80. And for our pods, what we have is called a label. So that's sort of the squiggly line thing. Our label is called app:/Nginx. And so essentially what happens with the service is it's using the selector to select everything with the label app:/Nginx to route traffic to. And so that's sort of the relationship between the selector and label, in which the selector selects things and the label things. And when you have the selector, it'll route traffic to things that the label coordinates to. Pretty simple, right? And so that is the image that I want to keep in your mind. As we go through the manifest files. So something that I felt was, So something that I felt was interesting was that every time I deployed a deployment, I just used Helm install. And the reason this was the case was because kube control commands were kind of confusing to me when I was first starting. I just wanted to hit something, have it work, not have to worry about the order in which I deploy my resources. And so that was sort of the case there. Let me go ahead and mirror my, I need to go ahead and mirror.
While she's doing that, I think that's where I'm at too.
So
what's that?
Second, so we can go
kube control or kubectl commands. Confuses me a little bit, but a little less now that I understand what it's just an API.
I don't know how to X this part out. I'll just
just press escape.
Okay, whatever.
Whatever.
Yeah, she just got the brand new computer.
Okay, let's take a second and hope the demo gods are with me
I noticed
today.
that you the computer you pulled into the shop the
so
same
we
as
have
her
part
computer.
1, which I'll just do a quick Helm
standard DevOps
run through of all my manifest files. So let's go into there. Part 1.
I like this angle too.
Yeah, I'd like it too.
Okay, so here is sort of the layout of what's going on, right? So at the very top under our part 1 Helm directory, we have our chart. So let's go ahead and cat that.
YAML templates.
Amy's awesome demo, description, version control your clusters. So this is sort of the metadata to describe each deployment, right? And so we're going to ignore the values.yaml for now because I'll do that in part 2. So let's go ahead and see the templates, and this is where all of my manifest files live.
Nice.
It's clear here. Oops. And so here what we can see is we have deployments, we have our Ingress controllers, and we have our service.
I remember.
So let's go ahead and cat out deployment and show you that it is exactly as the picture that I had before.
Nginxes.
So let's do a quick breakdown of this. So what we can see here is we have our deployment. So that's what is our resource. It is called Nginx. And then what we want to be able to do is have 3 replicas. So that means we want to have 3 pods up and running at all times. And then we're labeling this deployment app Nginx. And what we have is our container with the image of Nginx 1.13, and we're exposing port 80 on our Nginx container, right? So that's exactly what I described before in the image. Let's do a cat of our services. So this is the next layer, right? So we have our deployment. Now we want to be able to have our service group these deployments and pods together. Cool. So again, our resource is called service. We want to name it Nginx. I probably should have just called it Nginx service. Sorry about that. That'll happen in part 2. And we have our selector, and the label that it's selecting is app Nginx. What we're doing is we're routing the traffic to port 80. So that's our service. Let's do a cat of our ingress. Cool. Once again, same deal. What we have is an Ingress Controller. We're naming this resource Nginx. I wanted to add -ingress, but again, that's in part 2. And then what we want to do is so what we're doing is routing traffic to our Nginx service, and then we're routing traffic to port 80, and then we're exposing port 443 on our ingress. So let's go ahead. And fingers crossed, this will work, I believe. So Helm install part 1-Helm. Yay, cool. So what we see here is all I had to do was do Helm install part 1-Helm. In part 3, I will kind of show you the alternative of sort of the pains of how to do this manually with kube control. And so what this shows, let's do, our deployment is called filled Alpaca. So I like to always see the names of the deployments because they randomize it, and sometimes they're just really funny. Cool. And so nice. That is there. And then let me see if we can actually hit this endpoint. I think okay, cool. Let's do HTTPS so it doesn't yell at me. And then port 443. Something happened. Oh, wrong port. Yeah. 443. Yay, welcome to Nginx. So we're able to access this via the internet. Woohoo! Okay, cool. Let me do, so now the other cool thing that I want you to notice is just kind of notice how fast this all is, right? So let's do
super fast, right?
Yeah, it's crazy.
Delete, I hope. And then I'm going to delete this deployment, and then it's going to tear everything down for me.
Yeah.
In a second. Cool, yeah. So let's do a kubectl get pods, and we can see things terminating. So you can see everything in terminating status right now, and we know that Helm is working. It helped us terminate all of our pods for us with one command line tool. So let's go ahead and cd into part 2. And this is where I want to talk to you about the values file. And the values file, let's actually cat out templates / deployment. Okay. So what this does is that we're able to have a lot of configuration variables, right? So you don't want to always edit the actual manifest file itself every time. What you want to be able to do is just sort of plug in these configuration files. And this is really a simple example to be able to change each deployment, right? So what we have here is whatever the value for scale is within our value YAML file, let me highlight that, is going to be what's in the configuration file, and then whatever value we have in for tag in the values.yaml file will be placed there. So let's do a cat of values.yaml. Cool. So here we can see what we're doing is setting the scale as 3. We want to tag it for Nginx version of 1.13. So let's do clear ls. Okay, so let's do Helm install part 2, Helm values. Cool. And so let's super double check this and do kubectl kubectl get pods. So we can see that, yep, we have 3 pods up and running. And then what I want to do is kubectl exec and then our pod name. And I just want to like double check again that this is the version, I think I said 1.13, right? So -v. So all this is doing is execing into that pod and like running that command. Cool. So what we have is the latest version of 1.13, which is Nginx 1.13.7. And let's like do some upgrades and like rollbacks and things like that to show you how easy it all is. So once again, you'll note that like all this stuff is coupled together, right? Like one version is one set of manifest files.
Yep.
Okay. So I'm gonna go ahead and do clear. I have a little cheat sheet here in case I forget. Okay, so what I wanna do is do a Helm upgrade. And I have set, and what I wanna do, I want to set the values that I had before that you saw. So I want to set scale and I want to set image. So let me do set scale equals, let's go crazy and say 9. Okay. And then what I want to do is tag, let's say 1.12. Oops, what happened? Okay, tag 1.12. Like let's, I don't know, revert back for some reason because of reasons. Actually, let me do Helm list because we also need to set up the release there. Okay. So tag 1.12, let's put in our release. And then what we want to do is we want to upgrade with part 2, right? So part 2. Oh, thank you. Sorry about that. Good call. Okay. Release.
2 arguments.
Oh, okay. Thank you.
You're welcome.
Thanks, y'all, for the help. That's awesome. Okay,
that's what's good about doing these things in front of a bunch of nerds.
Yeah, exactly.
Get pods again. Okay, so we have some terminating. Let's see which one's the youngest one. Okay, 9 seconds. So what I want to see is that this is version 1.12, right? So let's do kubectl exec and then the pod name. So this is the 9-minute one. So that means this is like a new one.
Not 9 minutes, 9 seconds?
-- nginx -v. Let's see.
You put a space.
I forgot to, let's see what I did. I think I probably, hold on a second. So kubectl exec nginx -- okay, let's do some live troubleshooting here. So let's see, get pods.
Okay.
We have, oh, thank you. Live coding. kubectl exec pod, and then we put our pod -- nginx -v. Okay. Okay, let's see.
Pod's not found.
Thank you, everyone.
Pod is not found.
Pods. No.
Oh, man.
Okay, sorry about that.
It's tough to do that.
Okay. Let's, okay. So
that works.
there we go. Sorry about that. Yeah, it's like, but yeah, so now we see that we have upgraded to 1.12, and then we should also see that we have 9 pods up and running. So kubectl get pods. Cool. So now we have 9 pods up and running.
Nice.
So now let's go ahead and do a rollback. So what I want to do is Helm, rollback, and then I want to upgrade to revision 1. So let's do Helm list again to see what deployments that we've had.
Favorite thing about Helm.
So
what's up?
Helm,
rollback.
Rollback.
Versioning. It's version
and
control.
then this is our release, and then revision 1. Cool, so rollback was a success. So hopefully now what we want to do is check to see that we are now back on version 1.13 with 3 pods of our deployment. So this is going to roll back to our previous version. Cool. And let's do kubectl get pods again. So we can see that we have a lot of pods that are terminating. So this is, again, getting back to our desired state. So let's pull up this pod name. And then we're going to exec into this, and I'm going to make sure that this command is correct. And cool, so we're back on 113, and then what we should have is, again, 3 pods only that are up and running.
Yes, ma'am.
Cool, so this was our demo of Helm. Let's go ahead and kind of see the alternative of how kubectl works.
No.
So I'm going to do Helm list again, and I'm going to delete this deployment.
I actually do mean we stop this. We don't need to watch this.
Okay.
This is like the old way, the old painful way to do it, and why you should use Helm instead.
Mm-hmm.
And I don't see any point right now, right in this time, to go over that. You can go over that on your own. So, but my thing, I stopped watching it yesterday as well when she did the same one, because I'm like, well, why would I want to learn the hard way?
Well, I don't get that either. I found that like when I'm going through all the like all my coding courses or anything,
make you do it the hard way first.
Like, well, okay, this, because for JavaScript when I was learning it, this is how you do it when it's shitty. And now here's how we do it with object-oriented programming. Well, why didn't I start with that if that's the go-to now?
Okay. Correct. But so
I've never understood that.
So I have, and I'm going to have a little bit of a live demo thing and see if I can show you what I've learned about Helm today.
Okay.
So bring up the shell in your Ubuntu terminal. You can close this now. I don't think we need this anymore.
Okay.
Thank you, Amy.
Thank you, Amy. We're gonna. I'll throw you a like on this video.
You should subscribe to this.
I'll copy this link. Tomorrow. See, this is what you do when you're on the Cloud Brothers. You go to find our picture right there.
That's how you do it.
And then you click subscribe. See, we do it, and you click the bell for when she uploads.
7 years.
When CNCF
7 years of good luck. 7 years of good luck.
7 years of good luck if you like and subscribe to the Cloud Brothers. And CNCF. The foundation. So just let me, I'm going to pause this for a second.
Okay.
And through the magic of pausing and starting, thanks, Amy Chan, for your video. That time flew when we were watching it. It's really weird.
Yeah. Very good explanation. I like the baby computer inside of the parent computer. That's a good one.
I was trying to, I always say, like, when you finally learn something, you should be able to explain to, like, an 11-year-old about, like, it, like, whatever you're learning. And once you can do that, then you've learned your concept. And I think an 11-year-old would understand that. And I've tried to, and I have made the mistake of trying to teach people who don't know anything about cloud stuff, including containers, and I'm like, well, it's like
even containers, even the audience is, what is it? Nobody knows how containers work.
Yeah, exactly. Okay, so we're looking at Helm. You're going to tell me something. So I've got
so I've went down this rabbit hole a little bit, and what I do know, there's like a Helm create function which is built in that scaffolds your chart automatically, and it's an Nginx chart. Just one second.
Yeah.
Make sure it's not for me.
Yep. And if it is, we can pause for the cows.
Oh yeah, they're doing jokes, so yeah, it's fine.
Okay. Good.
They're doing joke memes, so everything's good.
Sweet.
So Helm create, and then the name of whatever app you want to do makes you a scaffolding of your things. So help create, and then space, and then go demo app.
I'll do what Amy did.
Okay, Corey demo. Yeah, okay. Corey's demo. Awesome demo. Okay.
Yeah.
You spelled AWS wrong.
Oh wait. I am gonna change it because I feel like I'm being exclusionary. Cloud Bros.
Oh yeah, okay.
Awesome. Oh wait, I'll go like this.
I'm gonna spell that. I'm gonna say like that every time now. You spelled AWS wrong.
See,
it is awesome.
There you go. And you think it's spelled wrong, but now it's spelled correctly. So
spelled correctly for what we want.
Creating
awesome
demo.
So now
AWS demo.
Yeah, I don't know PowerShell well enough to navigate through it. I don't know if it's cat or ls, but
well, it looks like it's cat because it turned yellow.
You gotta change into the directory though first, because you're not in the Cloud Brothers awesome demo directory.
Oh, so I have to go CD Cloud Bros.
Yeah.
Oops.
I think if you hit tab, it should start.
Oh, weird.
Yeah.
Okay, let me just
tab.
Oh, I see.
Yeah. CD and then start typing cloud and then tab. Yeah, there you go. Enter.
Okay, we're in.
And then I don't know if ls works in here, but I think dir does. Oh, ls does. Yeah. Okay, cool.
What am I LSing?
Just enter. So there's your directory.
Yeah, that's exactly what she's just talking about, just as fast.
That's what it made for you, just as fast. And so do the same thing, cat chart.yaml. That's capital letter for some reason. It fixed it. Oh yeah, it's Windows. Yeah. I can't see it's behind. Part of it's, you gotta clear it. It's part of it's behind.
Oh, or I guess I'll just go up. Does it have to be capital? I guess, does it care?
Well, it's supposed to be, but Windows doesn't care.
Oh, that's weird.
What happened there?
Oh, I think I just...
We just moved it.
It doesn't like it capitalized?
Okay, uncapitalize it. It's weird. My Windows is so much fun. Okay, so there you go. There's a whole bunch more notes in there, but that is your default created chart, right?
Yeah.
Your type is your application, version, app version 1.16. Do a ls again, or?
That'll work.
Yeah, and then you can ls the value, or cat the values.
Is that a YAML?
Yes.
Wow.
Yeah, and then there's the values that it uses for your default thing, so it gives you something out of the box to learn, right? Cluster IP, and so clear that again. What I'd actually do in a different mode is I would go through this in Visual Studio Code, but this is fine for what we're doing. So CD into your templates directory. This is kind of what I wanted to do, go through the demo that she did, and then it's just no YAML for that one. It's just templates.
Just templates.
Yeah. And then there's YAML files in there, so ls in there.
Oh, there you go. There's Ingress and
Ingress, service account,
helpers,
deployment.
The deployment, yeah.
We don't need to go through each one of them today. It's not the intent of what I wanted to show you. But CD space ... and CD space ... again.
Like twice? Just do it down?
Yeah. Do it, enter, yeah, and then do it again, yeah.
Oops.
Space. Okay, so now you're in the directory where your Cloud Brothers thing is, right? Your Helm charts for your Cloud Brother thing.
I believe so, yeah.
So you can do Helm install.
Mm-hmm.
And then Cloud Brother awesome demo. You just type that up.
So go Helm install.
Yeah.
Cloud. What was that? Cloud Bros.
It's right above you. You can just copy paste. It's
like right above me. I see.
Yeah.
That's pretty close.
Yeah, and I think that's all you need to do.
Error installation failed. Must either provide a name or specify generate name.
Yeah. Okay, so you got to say Cloud Brothers demo and then / Cloud Brothers demo. So you're naming it and then you're pointing it to the
So I got to put Cloud Brothers demo and then what? Dot?
No, then space and then /
Oh, it has to be /
I think so. Yeah. Yeah, I think that should.
Kubernetes cluster unreachable. Get the IP address, timeout.
Yeah. You got to start Docker. Is your Docker desktop running on your machine? I forgot about that.
I don't know.
Yeah, so just run your Docker get your Docker desktop running in the background. I'll entertain with a stupid joke. Why did the chicken cross the road to get to the other side?
Hey, do you know why the frog crossed the road? Because it was stapled to the chicken. Ribbit. Staple.
I don't know how to start Docker from PowerShell. So you might want to just do it off of Docker start. Yeah, I just go to Windows and start it from the thing at the top. Oh, Docker start. There you go.
Docker
I think that's for container. Yeah, that's not how that works. You actually have to start the Docker daemon.
Yeah, well, you can't see it because I'm not sharing my desktop. But the Docker engine is starting. It says there's a big thing on my desktop.
If it's starting, that's good. Perfect. In a couple of minutes, you can just up arrow and run that command again. I think you do Docker status, something like that. Yeah, so it's installed. Good. So Docker stats? No. I don't use command line Docker a lot. You could also use Minikube as well. But I don't remember how to start Minikube off the top of my head.
Hold on. Maybe this will do it. Hold on. I don't know if this will work.
No, that's for running a container. Docker and Docker daemon are different things. If you scroll up a couple of times, if the Docker desktop is running now, it should work.
Oh, okay. Wow. Yeah, it is.
Minikube. So just up, just up arrow in there. A few commands to
this one.
That one, yeah. That one, yeah. Doesn't like. Oh.
Target machine
actively refused it. Okay, so this is a Windows thing for Docker where you don't have.
Okay.
So are you an administrator? Did you start this as administrator?
The PowerShell? I don't think I did. Let me just.
Yeah, so try that. Try starting it as administrator. That's probably all it is.
One sec. Okay, all right. So we switched to you're streaming towards me now, so we can just get this done. So we can get this.
I wanted to show you just the install part, and part of doing the live demo is we weren't ready for it.
Yep, sure.
But that's okay. I have it. I was messing around with it, so I can do it. Just a quick reconfigure redo. So with Helm, create demo app.
Mm-hmm.
It's going to call it demo app. We've already gone through. All the files, and Amy went through them as well. So I'm not going to go through. I'm just going to install it right away.
Yep.
So Helm install and then demo. And demo. I think it's like that. Demo. Quit. Yeah, and I think that should work.
Demo-app. Yep. Yep. It says deployed or last deployed March 2nd at 6:44 your time, Vancouver time.
Oh yeah, deployed. Yeah, cool.
It says last deployed at right at the top.
But this is the interesting part. This is one of the interesting part about this thing is there's like a notes file in your charts, in your Helm chart, and what it does is it spits out these things at the end, and you can actually do get notes. But I'm gonna do all the things here just to wrap it up.
Yeah. Export pod name.
Pod name, and this all it's like the default app to learn it, so it's cool. And then export that one.
And so obviously this is with the mouse copy and pasting, right?
Yeah. I don't think I need this one because I know that one, right? That's just getting
the
notes.
Echo, yeah. Where the address is.
I know it's going to be 127, but I want port 8080 to map to or from. I'm not 100% sure. The container port, right?
Yeah.
So there you go. Forwarding port 8080 to port 80 on 127.0. So if I go to here and then go 127 and then 80, I think 80
should be 80.
It should be 80. Okay.
You might have to do.
There you go. You're right.
Yeah.
80. So that's the Nginx thing done by the health chart, Helm chart.
Helm chart, yeah.
That is just the demo app that is built from Helm create and then whatever you want to call it. So if you want to start a Helm chart, don't do it from scratch. That's build the scaffolding and then empty them all out and then change it.
Yeah.
That's the learnings there.
Yeah. Helm school, like we've done a little demo.
Got two more things.
Oh yeah, sorry.
Two more things. So I'm gonna cancel that.
Yep.
I think I don't know. I don't think it stays yet. And then it's not. Yeah. So it's
if your server's not running, it's got nothing to point to.
Yeah. So, but if I do Helm list. Shows you. Yeah. See, I've been messing around a little bit.
Yeah,
so I have demo app 1, demo app 2.
But your pod should still be there.
Do it's still there. Still running.
See, demo app says run updated last time 1844. That's your most recent one.
Yeah, and what I was actually trying to do was because the secret or why you want to have something to connect to a database, right? So I was actually trying to get a Postgres pod and Nginx pod and get them to talk to each other. That's where I'm going. But it's to me, I think I just want to get rid of that one and then wrap it up. I think it's Helm remove. I think.
Yeah, I forget what she said. It was
uninstall.
Helm uninstall. Yeah, I was going to say that. I thought she said Helm uninstall. Yeah. And we did that before when we did. I'll probably link the suggested video at the end of this video to our Helm tutorial walkthrough from AWS or whoever it was.
We should redo that with just the Helm part.
Yeah, well, why not?
Uninstall demo. Yeah.
Repetition's the mother of all success.
Yeah, release demo app uninstalled, and then Helm list.
Then that should be gone.
Like, I can't, like, dude, how can I do it any faster than that?
You can't. You can't.
I can't.
There's a lot happening. That's why the helm of a ship.
Yeah, like, we're waiting for a VM. I can feel myself becoming the crazy Kubernetes guy.
Well, yeah, me too. And like, why would you do it the hard way when you have this way? It's just, it's like the helm of a big, like a cargo ship or something like that.
Well, that's exactly the reference they use.
It's like the steering wheel, the helm, like the old helm, is just Kubernetes. But the helm is like you've got the captain there and the captain's assistant for the first mate, and then the other crew members. That's in a modern ship, or like or if you want to be a big nerd, like a starship, that you've got a whole crew. That's the helm, the entire area. So you think of it that way.
Here's the other one too. Oh no, what is it? Helm charts on GitHub.
Oh yeah, it's like there's going to be lots and lots.
Well, there's an official one. This one, GitHub Helm and charts. Oh, it's obsolete now.
That's what it says.
Obsolete.
Maybe.
All right, curated.
It said something like that when it said when I turned Helm on in the PowerShell, I had to put Helm sudo apt install Helm -- classic or something like that.
Yeah.
And then it went back. So maybe there was a change to it recently. Maybe a newer one somewhere got updated. Bitnami, yeah, maybe that's it.
There was a Bitnami one that I was working on.
Yeah, it could be.
Yeah, Apache. See, yeah, here. Oh, actually, this is kind of what I was after. It's like there's one for Apache. So just loop through this. Yeah, Kafka, Tomcat, Spark. There's a ton of pre-built charts already that I do a lot of things. I saw one for Jenkins. What else I see? One for Postgres, obviously.
Yeah. Oh, it's amazing. All right. Do you have anything else for this?
No, that's it.
So at the end of this,
Kubernetes guy's done.
I'm going to point to our other video as a suggested video, and then we'll probably make another one. Like maybe even making a real life project that will.
I think a produced Helm one would be good, and a project.
Like leave one up that can just stay up live. That doesn't cost us that much money. On our new official website, which I own. Well, the domain anyway. Announcements to come once that gets going. All right. Thanks for watching. Like and subscribe. Hit that notification bell because we love you, and thanks a lot. Goodbye, Cloud Brothers. Woo!
Couldn't get it.